The circle C with centre C58 touches the y-axis as shown in the diagram. Express the equation of the circle in the form here. Verify that the point A212 lies on the circle. Find an equation of the tangent to the circle at the point A, giving your answer in the form Sx plus Ty plus u equals 0, where St and Ui are integers. The points P and Q lie on the circle, and the midpoint of PQ is M712. Show that the length of CM is n root 5, where n is an integer. Hence, find the area of the triangle PCQ. So it's a long question. I've got it all in summary form here. The first thing to do, and I'm going to write it underneath this, express this circle in the form here. So I'm going to put the answer for part A here. This centre is 5,8, so this distance here, oh, it's got a centre 5,8. And it touches the y-axis, so the amount here is the radius is 5, so x minus 5 then, squared, plus y minus the 8 squared is equal to the radius squared, which is 25. 5 squared is 25. Verify that A212 is on the circle. So part B now then. Let's verify that then. Here, let's put it in. 2 minus 5 squared plus 12 minus 8 is equal to minus 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, so yes, it is on the circle. Find the tangent at A in the form of this. Tangent at A then. A is on the circle and we want the tangent. Okay, A is 212, so we've got 2 and 12. So it's probably going to be about here, isn't it? There's A then. And we want a tangent at A. So I've just drawn a line here to represent the tangent. Okay, so this is a right angle. This is of distance 5. A is that, isn't it? So what gradient is this line? Well, this is 2 and 12, isn't it, as we said. So what's the gradient of this line? Then we can get the gradient of the tangent. So gradient of AC. So part 2. So the gradient of normal, which is the normal, is, so what's the gradient of the normal then? Well, it's the increase in y, so we go from 12 down to 8. So that's an increase, we're going down 4. The increase in x, we go from 2 across to 5, don't we? Horizontally. So that's an increase of 3. Is 4/3. So tangent, well, we can just put it in the formula now then, can't we? So y minus the y value, which is 12 at A, equals the gradient of the tangent, which will be 3/4, times x minus the x value at A. Now we'll move the 4 up to be with the y. So 4 of this, so 4y minus 48, 4 of both of these, is equal to 3 of both of these, 3x minus 6. We need to write it in the form of this plus this. So move the 4y over, 3x minus 4y then. Move the 48 over, to plus 48 takes 6 is plus 42, equals 0. So there's our equation of the tangent then. Okay, that's the tangent then. P and Q lie on the circle with midpoint M. Show that the length CM is the n root 5. So P and Q lie on the circle with midpoint 712. So 712, 5, so 712 would be here, wouldn't it? just here. It's going to be the same but there. Sorry about the sketch now. I'll draw it in a different colour to try and help. So there's 7 12s there. It's the same height as that one. And then you've got P and Q here. And say that's P. And this line is a straight horizontal line, isn't it, across to there. Okay, it's something like that. The midpoint is not on the circle, but it's the same height, so it's a horizontal line. And then we need to work out the area PCQ, so we're coming down here, aren't we? So we would know that length. Okay, right, and then what? Find the area PCQ. P, C. C is the center, wasn't it? Q. Okay, so first of all, show the length CM. C to M to the base. Ah, there we are. That's fine. So C to M is n root 5. So let's do that then. The center is 5, 8. So part C. Center is 5 and 8. The midpoint M is 7, 12. So length CM then is equal to, use Pythag, the horizontal distance difference is 2. So it'll be 2 squared on the horizontal. 8 to 12 is 4 squared. Let's just check M is 7, 12. Yeah. And C is 5, 8. That's fine. 4 squared. 16 plus is 20. And we square root using Pythag root 20. Which is equal to 4 5ths to root 5. Which is what we wanted to show. Hence find the area PCQ. Well, simply it's half base times height, which we know. Half base times height, P and Q. Is n root 5. Ah, okay, so let's just draw it then in here. So there's C, and this was distance 2 root 5. Here's M, 5, 8. Here's M, which was 7 and 12. And here's P and Q, like so. And we know that this is a radius. This is a distance 5, and this is a distance 5, of course. This distance was 2 root 5, so using Pythag, we can work out this distance easily. It will be the square root of 25 squared, 5 squared, which is 25, minus this squared, which is 20, which is root 5. So I've just used Pythag to get that. So area of PCQ is equal to a half base. Well, the total base will be 2 root 5. So it's root 5 then, half of that, times the height, which is 2 root 5. So we get an answer of 10 units squared. So it's helpful to draw a picture here, isn't it? So we can see exactly what is what. So P and Q are there, say. And what we did was we recognised M was 7, 12. We recognised what P was on the circle, so that distance had to be 5. We knew this distance was 2 root 5. Then we used Pythag to get this, and we can just check that by saying this squared is 20, this squared is 5, so that would be 25 when added. Square rooted gives 5, so this is correct value. And then it's half base, which is the root 5, times the height. So it's 10 units squared.